photosynthesis is broken up into two major reactions. Okay, the light-dependent reactions, okay, must have light, and then the light-independent reactions. They used to be called dark reactions, but they're not anymore because the dark reactions can occur in the light, but they are light-independent. All right, so the first stage needs light. All right, so if we look at this diagram, okay, I'll have to go over and explain this. Okay, so okay, here's energy going up here. Okay, so light comes into this system. Okay, now we're in the thylakoid membrane now. Last time we talked about photosystems. Okay, so this is photosystem 2. It's called photosystem 2 because there's photosystem 1 over here. Okay, which was discovered first. This was discovered next. So it's number 2. But actually, that's where it starts. Light comes in. Okay, and is it called that in the photosystem that electron from a chlorophyll A molecule, okay, gets bumped up to a higher level within that membrane. There's a primary acceptor up here. It's called plastoquinone. So that's an electron acceptor in the membrane. So it's now at a higher energy level. Okay. So if you think back to those, remember those gas discharge tubes in chemistry, okay, where you run electricity through it and the atoms give off light, certain colors of light. Well, that's kind of what happens here. These electrons get bumped up to higher levels, or they get excited, and now they're at a high energy state here. Right? So you've got that electron at a high energy state there. Now, of course, you have chlorophyll down here, which is now lost an electron. To replace that electron, it comes from water. I mentioned this last video, but water gets split, okay, into hydrogen ions, okay, and the electrons. And these electrons will then replace the electrons lost by chlorophyll. Okay. To keep it balanced, we're going to go with 2 electrons being transferred along the pathway here. So those electrons leave there. You get hydrogen ions here, okay, plus oxygen. Now, a key thing for this is that these hydrogen ions, they're produced inside the thylakoid space. Okay, so if you remember, we have a thylakoid membrane, which is that third membrane, okay, within the chloroplast. Okay, inside of that is the thylakoid space. Outside is called the stroma. Okay, that's key for you guys to remember. So this is occurring inside that thylakoid space. So what you're doing when this happens, I'm going to move over here where we actually show the membrane here. That should look familiar to you. Phospholipid bilayer there. And here's photosystem 2 here. Here's photosystem 1. Here's that what I just drew here. And you're producing all these hydrogen ions. Okay, so what we're setting up is what is called a electrochemical gradient. Okay, electro because there's more positives here. Okay, and chemical because there's more hydrogens here than outside. Okay, because of their charge, okay, they can't get through this membrane, so they build up over here. But there is a pathway for them to get back. Okay, it's through this protein complex, okay, with an enzyme attached called ATP synthetase. Okay, ASE, it's an enzyme. Okay, it's located here. So what happens is these hydrogen ions build up, and then they come storming back through this channel, okay, and that provides the energy to make an ATP molecule. Okay, so I didn't a little short for space here, but ADP would make ATP. So you're making ATP, which you know is an energy molecule. So now some of that energy is stored up in that ATP, but it's set up by this electrochemical gradient across the membrane. That's how it's produced. So you got ATP produced that way. All right. Then over here, let's go back here. You got these electrons, which are accepted up here. Now we're in the membrane, and now we go through a biochemical pathway in which these electrons are being transferred. Okay, if you recall back, there's things called oxidative reduction reactions, Leo-Gur. Okay, so gain electrons, it's reduced. Okay, lose electrons, oxidized. Okay, so when you gain electrons, you're basically gaining energy. So we say this plastoquinone, after it's accepted these electrons, it's at a higher energy state, okay, than before. Okay, so we say it's been reduced. Okay, then when it loses its electrons to the next one, this may be like cytochrome B, a different one in the membrane. Okay, it loses those electrons. Now it lost them, so that's oxidized. But this cytochrome here has been reduced. Okay, so you have this whole series of reactions here. Okay, and when you do that, you set up another proton gradient here. So you pump these hydrogens out, okay, along with the electron. Electrons stay, the hydrogens get pumped out, and you can make more ATP that way. Okay. Okay, so that's contributing to this electrochemical gradient, producing more hydrogen ions. Okay, then photosystem 1, another photon of light comes in. Okay, okay, for this photosystem 1, the electron is not replaced by water. And photosystem 1 is replaced by the electron from photosystem 2. Okay, so electrons come in here, and it replaces electrons here that can get kicked up to an acceptor over here. Okay, and as they fall down here, okay, the last thing this electron does, it contributes electrons to NADP plus, okay, plus hydrogen ion, and you make NADPH. Okay. That is a reduced coenzyme. Okay. So that's where the energy is. You're going to use this as an energy source, and you're going to use ATP as an energy source, okay, to make glucose, which will be in the light-independent reactions. All right. So I know I kind of went through a lot there, right? And then, but I think in the PowerPoint, may point out some things you can get clarification there, and also when we go through the Zoom class. But that's basically what happens in light dependent. Okay, so the key things that are produced in light dependent reactions. Okay, of course, light comes in, but what's produced is oxygen, which is of course key for aerobic organisms, and NADPH and ATP. Key products of light dependent reactions.